Hey there, science fans! Today we're diving into the fascinating world of stoichiometry. Don't let the big word scare you. It's easier than it sounds. Stoichiometry is like a recipe book for chemists. Just like a recipe tells you how much of each ingredient you need to make a delicious cake. Stoichiometry tells us how much of each chemical we need to make a chemical reaction happen. It's all about the right proportions. For example, imagine you're making a simple cheese sandwich. Your recipe might say 2 slices of bread plus 1 slice of cheese equals 1 cheese sandwich. That's stoichiometry in action. You need the right ratio of bread to cheese to make a perfect sandwich. So, why should you care about stoichiometry? Well, it's more important than you might think. It plays a crucial role in many different fields, from baking to rocket science. Let's start with baking. Ever wondered why your cakes sometimes turn out flat or your cookies are too crispy? It's all about stoichiometry. If you don't use the right amount of each ingredient, your baked goods won't turn out right. Now let's blast off to rocket science. Stoichiometry is essential for calculating the exact amount of fuel and oxidizer needed to launch a rocket into space. Too little fuel, and the rocket won't reach orbit. Too much, and it could explode. Before we dive deeper into stoichiometry, we need to talk about moles. Don't worry, we're not talking about the furry little creatures. In chemistry, a mole is a unit of measurement. Just like we use dozens to count eggs, we use moles to count atoms and molecules. Atoms and molecules are incredibly tiny, so we need a really big number to count them. That's where the mole comes in. 1 mole is equal to 6.022 times 10 to the 23rd atoms or molecules. That's a huge number. It's like counting every grain of sand on all the beaches on Earth. Why is this important for stoichiometry? Well, chemical reactions happen at the level of atoms and molecules. So to understand how much of each reactant we need a way to count them. And that's where moles come in handy. Now, let's unlock the secret code of chemical reactions, mole ratios. Remember our cheese sandwich recipe? It told us we need 2 slices of bread for every 1 slice of cheese. That's a ratio. Chemical equations have ratios too, but instead of slices of bread and cheese, we use moles. These mole ratios tell us the exact proportions of reactants and products in a chemical reaction. For example, the chemical equation for water is 2H2 plus O2 produces 2H2O. This equation tells us that 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. It's like a recipe for making water. Real-world stoichiometry, from antacids to airbags. Stoichiometry isn't just something you learn in a chemistry lab, it's all around us. Let's explore some real-world examples. Ever get an upset stomach? Antacids rely on stoichiometry to neutralize excess stomach acid. The right amount of antacid will neutralize the acid without making your stomach too basic. In a car accident, airbags inflate in a fraction of a second, protecting passengers from injury. The rapid inflation of airbags is a chemical reaction that relies on precise stoichiometric calculations. Too much reactant, and the airbag could explode with excessive force. Too little, and it won't inflate properly. We've already talked about baking cakes, but stoichiometry is essential for all sorts of culinary creations. From brewing the perfect cup of coffee to fermenting grapes into wine, it's all about the right proportions. These are just a few examples of how stoichiometry plays a vital role in our everyday lives. It's the science behind many of the products we use and the processes that keep us safe and comfortable. Section 6. Stoichiometry in action. Baking the perfect chocolate chip cookie. Let's say you're craving some delicious chocolate chip cookies. Your recipe calls for 1 cup of butter, 1 cup of sugar, 2 eggs, 2 cups of flour, and 1 cup of chocolate chips. Now, imagine you only have half a cup of butter. Stoichiometry tells you that you'll need to adjust the other ingredients proportionally to maintain the delicious balance of your cookies. You'd use half a cup of butter, half a cup of sugar, 1 egg, 1 cup of flour, and half a cup of chocolate chips. See? Stoichiometry helps you bake the perfect batch of cookies every time. Section 7. Balancing chemical equations. getting your chemistry equation in sync. Before you can do any stoichiometry calculations, you need a balanced chemical equation. Think of it like balancing a seesaw. You need the same amount of weight on both sides for it to be level. In a balanced chemical equation, you have the same number of each type of atom on both sides of the arrow. This shows that matter is neither created nor destroyed in a chemical reaction, just rearranged. To balance an equation, you can adjust the coefficients, the numbers in front of the chemical formulas. It's like a puzzle, and it might take a bit of practice, but once you get the hang of it, it's a piece of cake. Section 8, let's practice. Some stoichiometry problems to solve. Ready to put your stoichiometry skills to the test? Here are a couple of practice problems. 1. The combustion of methane, CH4 in oxygen, O2 produces carbon dioxide, CO2 and water, H2O. How many grams of water are produced from the combustion of 16 grams of methane? 2. Sodium Na reacts with chlorine gas, Cl2, to form sodium chloride, NaCl. How many grams of sodium chloride are produced from the reaction of 23 grams of sodium with excess chlorine gas? Try solving these problems using the concepts we've learned about moles, mole ratios, and balanced chemical equations. Don't worry if you don't get it right away. Practice makes perfect. Section 9. Conclusion, Stoichiometry. Your key to understanding the world around you. Congratulations! You've journeyed into the world of stoichiometry and emerged with a newfound appreciation for the recipes that govern our universe. From baking cakes to launching rockets, stoichiometry is the unsung hero of countless processes. Remember, stoichiometry is all about the right proportions in chemical reactions. Moles help us count tiny atoms and molecules. Mole ratios are the secret code to understanding chemical equations. Balanced chemical equations are essential for accurate stoichiometric calculations. So, go forth and embrace the power of stoichiometry. It's a powerful tool that can unlock a deeper understanding of the world around us. Keep asking questions, keep experimenting, and keep exploring the wonders of science.